Thank you. So, yeah, I'm Michel Honoré. I was educated here 25 years and 8 months ago. I was over at the Department of Physics working with laser optics and running around the basements where the optical tables are, building holograms and building lasers and stuff like that. But I've been with Force Technology for almost 20 years working with these laser-based technologies. So I'm sorry, I don't know anything about buildings except what I know from living inside of one. So this will have a completely different aspect or different outlook. But let's see if I can make it match in some ways. So just a brief introduction about what Force Technology is, because see, there's a lot of foreigners here, and even in Denmark, we're not that well known. What we are is what in Danish is called a GTS, but in international language, it's an RTO. So that's a research and technology organization. I'm so pleased that I was put in between the industrial talk and the university talk, because that is where we are. We are bridging the gap between academia and industry, trying to bring out knowledge and R&D to the actual real world. There's a few of these institutes in Denmark. One of them used to be here, actually, at DTU, but it's relocated. I was employed there as well. So I did say we are in the middle of industry and academia trying to bring out the R&D. So let me give you a couple of examples of that as seen from the additive manufacturing side. But it's not concrete. It's going to be metals. So I don't work in any concrete. I don't work in polymers or what else you would see, but I do work in metals. And why would you even want to go for additive manufacturing? That's a question I get often. People think, well, we can 3D print everything, but why would you? And usually it's because of you having supply chain issues. You can't source the materials. Maybe you want to decrease your lead time. Maybe you want to decrease your price. Or maybe there's an environmental issue that leads you to additive manufacturing. And if we look at the environment, this I stole from a very nice LinkedIn post. This is the temperature over the year, starting at 1893, and we're moving up through time. So you can see the temperature of the Earth is increasing, increasing, and increasing. It's been like that for the past 130 some years, as you can see. But now we're getting into the industrial times, and it's speeding up. So something is going on. And whatever the orange man on the other side of the ocean says, this is a reality. So there might be some incentive in reducing the material consumption in the world. Yeah, let's just run it to the end. It's not that far. So you can see stuff is going on. There is definitely something happening. And if we tilt it, you'll see an acceleration over the past few decades. So there's an incentive in terms of green or less materials consumption in the world and not letting out too much CO2 into the atmosphere. So I usually say that green is the new black. We want to go greener because there's so much to be gained and so much to lose if we don't do it. There's the less materials consumption. There's, if you lower your materials consumption, you will lower the price of whatever part you're building. If you can produce locally rather than have someone machine or whatever it is your part is, however it's being brought to life, you can shorten your lead times. You can lessen the need for transportation of your parts. Again, this will lessen the release of CO2 to the atmosphere. Of course, also if you could recycle any product that goes into being, well, you would not need to build a new product, and then you would not emit CO2 for building new products. So let's have a look at what we do. And I'm sorry, it's all metals, but that's what we do at Force Technology. So it looks a bit different. I have what I think, at least what I thought was a big printer until a couple of moments ago. This is huge in metals. This is the biggest printer I've ever seen. It's 8 meters by 7 by 4. So it's not quite cobot size, but we're getting there. And if you look at what else you would find, like go up to the 4th quadrant of DTU, the building starting with 4, up the other end, you would see people building stuff in metals, but it would all be in little boxes. So all the metal printers are usually capable of printing something up to the size of a football, and that's it. We can print large size. So that's the machinery I work with. And how it works is it does not spit out concrete, but it spits out little metal particles, and we melt them with a laser beam. And once we move the laser beam away, the particles will solidify, and you will have a wall of metal. And you can stack the walls just like cobot do with their concrete. We can put them side by side to increase the thickness, etc. You get the drift. What we run into with this is, of course, if you're stacking stuff, people will start to look at, is the quality okay? How can you be sure that this is not going to break apart in every one of these layers that you've been stacking? And if you're working with particles, people will start to look into how will this function if some of the particles do not melt into the laser beam? So you will have particles that are just sitting inside the structure. Or what if some of these, the laser beam generates porosities because you will evaporate some metal. Maybe you trap evaporated or vapors or something inside, so you will have porosities. So there's a lot of quality stuff going on, and people are worried about the quality when you're printing. I suppose you'll have seen the same issues printing in concrete. But this is what we're faced with, is the quality okay? This is the stuff that I just managed to put in like 15 minutes ago. A print we did with someone who do work with actual buildings. We didn't print the building, but Bjarke Ingels Group, or BIC, approached us and said, we are building something. We're building a whole new quarter in, I think it was somewhere in Stockholm. At least it was in Sweden. And they wanted to show the public what this new area is going to look like. So they said, can you print us a city model? And we started out by printing something in polymers. I know I said we don't do that, but we do just for scale. So we printed a small model, like dinner plate size, maybe a little bigger. And they said, yep, exactly, that's what we want, but we want it in steel. We want to put it out there, out into the city, so the public can go and see how the buildings are going to look, what's the city layout going to be. And we want it to be SWEDE proof, so they can go there drinking beer, falling over, and it will not take any harm. So we build it in stainless steel. And when I say build, I mean printed. And the size of this is approximately 1.5 meters in diameter. So it's a huge disc, and we just started printing steel on top of it. A lot of heat going into the part, so even if the base plate was, I don't know, 50 or 80 millimeters thick, it deformed a lot, so we had to take it out and bend it into shape again. Another case we were involved with, you may have seen, we did not print this, but we did a lot of the calculations for it. This is the bridge printed by MX3, MX3D, I think they're called, somewhere in Amsterdam. We were involved in some of the calculations and in setting up sensors on this, because this is fully sensorized. So it will sense whatever is going on when people are walking across, et cetera, et cetera. So we were part of that project as well. And this is from the opening day when the Dutch Queen is crossing the bridge.
And the form, do you want to say just a word about the...
We were not involved in the shape of it at all. So that was an MX3D part. We did the calculations to see that it would actually work. We've got a lot of CFD people, and we've got a lot of FEM people who can work on that kind of thing. So we were involved only in the beginning, and once it was done and we could apply all the sensors, but not in the printing, not in the shaping.
Why sensors?
I'm not quite sure. I mean, they wanted to I think they want to inspire confidence. So they want to be able to monitor what is going on, because there's deformation when you cross a bridge like this. And they want to know what is the fatigue loads and stuff like that. So it's really a DTU thing, even if it's not DTU, but it's something for the scientists to get data out of this, to see.
Still up. It's still up in Amsterdam.
It is, yes, yes. I think it's a permanent bridge.
Yeah. Very impressive.
Yeah. Right. So I didn't know exactly what to expect to talk to you guys. I didn't know of your project. I'm sorry. So what I did decide to bring was an example of what we can do with 3D printing and additive manufacturing technologies. And this example is from our local railways here in Denmark. We have these quite old trains that should have been replaced. Are there any Italians here? Okay, good. We bought some newer trains from Italy. It did not work. So we had to fix these trains so that they would increase their lifetime by a significant amount of years. And what happened was the couplings of these trains would get worn and they would stop working. So they approached us and said, can you remanufacture these? Instead of us buying new parts in Italy, it takes forever. They ship them to Denmark. There's a lot of CO2 consumption in the trucks going back and forth. And every part weighs about 36 kilograms of steel. Can you just remanufacture the old ones? So we took in the old parts. We added 2 kilograms of steel for the remanufacturing, and we shipped them back. And they put them onto the trains, and it worked again. So by that, we saved about 95% of the material. We did it at a cost that was 60% lower. So there's a lot of incentive. And then some of the R&D guys back in my office said, hey, let's calculate how much did we save on this for the environment. And it turns out, if you look at this sustainability thing, it's like looking at an elephant. I don't know if you know this very, very old, I don't know what to call it in English, but there's an old analogy. If you put a couple of blind people in front of an elephant and ask them to describe it, it depends on what they're seeing with their hands. So since they're blind, they won't know the whole picture of an elephant. One will touch the trunk and he'll say, oh, it's like a snake. So elephants are like snakes. Another guy will touch the stomach and say, whoa, it's huge, it's like a wall. So the elephant is like a wall. And the third guy will touch the tail of the elephant and say, this is like a rope. So depending on what part of the elephant you're seeing with your hands, you'll get a different picture. And it turns out we did the same thing. So we did this CO2 carbon emission study on the train parts that I just showed you. And the comparison we did was, what if I make a completely new part, I cast it, I do that back in Italy where the factory is, I transport it to Denmark, and I put that into the train and let it run. The alternative that I'm comparing with is take the old worn part, remanufacture the worn surfaces, use just a couple of kilograms of steel, and we try to compare how much CO2 did I not emit into the atmosphere by doing the left-hand trick rather than building a new one, transporting over long distances, et cetera, et cetera. We did this cradle-to-grave calculations. The thing is, we were smart at Force Technology and said, hey, let's talk to the metallurgists. Let's make sure that when we renovate this part, we don't just copy the old properties of the part, but we enhance them. So let's put an alloy on there that will last forever. And they told us to use a certain alloy. We did. And this alloy contains a lot of cobalt. And cobalt is just poison to the environment. So mining cobalt emits a huge amount of CO2. So it turned out that in this comparison, even if I'm just using 2 kilograms of this fancy alloy with cobalt, rather than producing a brand new part and bringing it 2,000 kilometers from Italy weighing 36 kilograms, I'm emitting more CO2 to the atmosphere in the 2 kilogram process than in building a new one, transporting, etc. So that appeared to be a shitty deal for the environment. But then we remembered that we did put this alloy on, this new fancy cobalt-containing alloy, to increase the lifetime of the component. And even if it's just increased by a factor of 2, and it turns out it's probably more a factor of 4 to 8, then it's a pretty good idea for the environment, because now the component lasts a lot longer. So we don't need to replace it as often. And that means that we're actually saving quite a bit of CO2 to go into the atmosphere. So it depends on how you look at things. And if you look at the full picture, you will get a different story than if you're just looking at parts of it. So make sure if you're doing these CO2 emission calculations that you're comparing apples to apples, that you're actually looking at the full picture, because otherwise you might be misled. So I don't know what you're seeing here or what you think you're seeing, but you need to look at the full picture. That's what I'm trying to say with your CO2 calculations as well. So from an industrial standpoint, people will usually say, in order to go to additive manufacturing, 3D printing or whatever, is there an incentive? Is it the green agenda talking? Is it monetary issues? Does this really pay off to just move from traditional manufacturing methods to additive? Or do you have lead time, supply chain issues, so that it would be easier for you to just print your parts where you are? Or is there a legal requirement that says, no, you can no longer do what you did yesterday, now you need to do stuff in a smarter way? I don't know, maybe legislation that says you have to emit less CO2, for instance. So there need to be some kind of incentive. And usually, at the end of the day, money talks. So whether the incentive is you save material, you have less cost in terms of the way you build things, or it's a legislation thing that says if you're emitting too much CO2, there will be a fine to your company, or whatever it is. It doesn't really matter. At the end of the day, money talks. Fortunately, in these, I haven't presented all of these examples, but these are different things that we have 3D printed, and it always turns out that it's a good business idea, just to print. So, well, that's why we printed these items. In many cases, it is not a good idea, but there's a lot of incentive in just money. So in summary, I'd say for 3D printing, additive manufacturing in general, now with the new machines, the large robot we have, the huge ones Cobot has, there's a new potential to think outside of the box. You're not limited to printing football-size items. There's huge 3D printing capabilities out there. But what I'm seeing is that the print technology needs to gain traction either via dissemination, just talking about it, telling people that it's there, that the options are available, and that the quality is okay. Because we need, at least on the metal side, to inspire industrial confidence in the products. We need to show that you can build product that does not have all of these flaws from porosities, delamination, whatever you might think of. In some cases, I think we need more legislation to push us towards new technologies that are greener. And when I say legislation, it's often the sad part about it, where you get fined if you're emitting too much CO2, for instance. And then I think there's a lot of greenwashing going on. People are talking about how they're saving the environment by going to additive. Well, I just want to make sure that you look at the full picture when you do these calculations, because you might be misled. But at the end of the day, additive manufacturing is going to be a new technology only when it saves money for whoever is using it. And that's all I had.
Thank you so much. Thank you.
To learn more, visit am2pm-project.eu and follow for updates.